Okay, so this is problem number 5 on segment proofs part 2. This proof is actually going to be very similar to one we did last week. The only difference is that the figure looks a little bit different, but the steps are going to be very similar. When you have a proof like this where you have a bunch of pieces of segments, you probably are going to end up using the segment addition postulate. And you're also going to probably be using the addition or subtraction property of equality. And that's kind of similar to what we're going to do here. So let's kind of mark this up and see what we're trying to prove here, and then we'll go ahead and make our 2-column proof. So first, the given, there's 2 pieces of information. AY is congruent to XY. So that means this segment from here to here is congruent to this segment from here to here. Okay? And then we also have that YZ is congruent to YB. So we'll mark those as congruent as well. And what we want to try to prove is that AB is equal to, or congruent to XZ. All right. So it kind of makes sense. Like if you were to just talk it out, you're like, well, if these 2 things are equal or congruent, and I'm kind of putting another congruent segment on the end of 2 things that are already congruent, then the big thing is going to be congruent. So we're going to have to add some stuff. Which means we're going to have to do equality versus congruence. So the first step we're going to do is we're going to move out of congruence into equality so we can start using some addition ideas. So let's go ahead and set that up and we'll walk through it together. Okay, so we got statements on the left, justifications on the right. And again, the first statement is just going to be our given. So we know that AY is congruent to XY. And also we know that YZ is congruent to YB. And that's given. Okay. Now what we're going to do from here is we're going to move into equality. So we want to use the definition of congruent segments to be able to just say, well, if these are congruent, that means their measurements are equal. So what we're going to say is that AY is equal to XY, and YZ is equal to YB. So now we're talking about measurements here. So these are numbers now. Let me make that a little bit easier to read. All right. Now you could do these in 2 separate lines if you wanted to keep it clear. You don't have to though. So whether you want to do these 2 separate lines or 1 line, it's kind of the same. But this is the definition of congruence that allows us to move from congruence to equality. Remember, it's our bridge between congruence and equality. So that's a definition of congruence there. Okay, now there's a step that we're going to do, and it doesn't really matter where it comes. This can come later, or it can come earlier in the proof. But what we're going to do here, I think when I did a proof like this before, we went right into the segment addition postulate, and then later I did some addition property of equality. But I'm going to actually do that up first just to show you that the order that you do it in doesn't matter. Okay, so what I'm going to do is I'm going to take this statement right here and I'm just going to rewrite it, but I'm going to add the same thing to both sides. So if I had this guy, AY equals XY, I could do something like this. I could do something like plus 5, right? Add 5 to both sides. Now, we're not going to add 5 here, obviously. We're going to add a segment. But that's kind of the idea. That's the addition property of equality. So we're going to add the same thing to both of these. And what we're going to add is we're going to add this guy right here. We're going to add YZ. So we're going to go, this is our equal statement right here. We're going to put XY, yeah, right here. Okay, so on both sides, what we're going to add is we're going to add YZ. Now, it may not be immediately obvious why we're going to do that, but just hang in there with me, it'll make sense in a second. So we're going to go plus YZ plus YZ, right? So I took this statement right here, and I just rewrote it. All I did was I added YZ to both sides. We can do that. That's the addition property of equality. Okay, now again, like That may not be super obvious why why we want to do that, but you're going to see in just a second. Okay. What I can do, what I know, is I can replace, anytime I see a YZ, I can replace that with a YB if I want to, because they're equal. We have these two equality statements. So this equality statement is basically right here. All I did was add YZ to here and add YZ to here. But now I can replace, if I see a YZ somewhere, the second equality statement says I can replace it with YB. So what I'm going to do is I'm going to take this statement and I'm going to replace this guy with YB because YZ and YB are equal to each other. On the right hand side, I'm just going to stay exactly the same. Okay? And the reason I can do that is the substitution property of equality. If I know that YZ and YB are equal, I can replace that YZ with YB. So that's all it's changing from here to here. From here, this statement to this statement, all it's changing is I'm replacing this with this, because they're equal. So that's the substitution prop of equality. Okay? Okay. Now again, I could have done that like in a later time. I don't need to do that right after this, but we're going to actually leave the proof here for a second, and we need to switch gears and talk about something else, and then we're going to put two statements together. So this is an important idea. We're kind of stuck for right now. We need to bring in another idea before we can move on. And the next idea is going to be the segment addition postulate. Okay? So if look at what I'm trying to prove. I'm trying to prove that this segment AB is congruent to this segment XZ. So right now, I don't have any, I don't have AB yet. I don't have XZ. All these statements, they don't have ABs or XZs in them. And so what I need to do is I need to kind of use the segment addition postulate to figure out what is AB, how do I get AB? So what we're going to say is that AB is equal to AY plus YB, right? The long segment is equal to the sum of the two little segments that make it up. So AB is equal to AY plus YB, right? Segment addition postulate, okay? Now I could have written, so the next line is going to be very similar, but it's going to be this segment, right? XZ is XY plus YZ. So the long segment is the two small ones added up. So XZ is equal to XY plus YZ. Again, that's the same thing, segment addition postulate. Now in a proof, you could have put these in the same line, but these are kind of long statements, and so putting both of these in the same line can be a little bit tricky. But yeah, it's the same justification, we're just doing it twice. So that's the segment addition postulate. So let's take a look at these two ideas, right? AY plus YB is equal to XY plus YZ, right? But also, where do we see this? It's right here. And where do we see this? It's right here. Okay, so if this, right here, AY plus YB is also equal to this, if this guy is equal to this guy, and this guy is equal to, let me go back one step, this is where it gets tricky. I have this statement and this statement equal, which means this statement and this statement are equal, which means this guy and this guy are equal. Okay, so one more time. AY plus YB equals XY plus YZ, but this stuff is equal to this, and this stuff is equal to this. So what I can do is I can replace this statement, I can rewrite this guy right here, but instead of writing AY plus YB, what am I gonna write here? AB, right? Instead of this chunk, I can write what it's equal to, which is AB. Okay? Instead of this chunk, I can write what this is equal to. And what is it equal to? XZ. Okay, that's a substitution property. I'm just taking this statement and rewriting it, but I'm using these two statements to allow me to substitute. So this statement becomes this statement. I replace AY plus YB with what it's equal to, and I replace XY plus YZ with what it's equal to, and then I get this statement, which is almost what we wanted, right? So we use the addition property of equality to get these two statements, And then we use the segment addition postulate to get these two statements, and then we use another substitution. So this is the substitution prop of equality. Okay, now how are we going to get from this to congruence? Definition of congruence. So AB is congruent to XZ. Definition of congruence. And that's what we were out to prove. Okay, so very, very similar to a proof that you had in the last homework. We need to use the addition property of equality. We need to use segment addition postulate. We put those ideas together. This is a little bit longer than the first 4 proofs in this assignment, but it's pretty doable. It's in the middle, it gets a little bit complicated sometimes, but if you need to run back through, watch it again, make sure you understand those steps, and the next proof that we're going to do is going to be also similar to this. So once you do a few of these and you get kind of the hang of it, you'll start to recognize the next steps. And yeah, more experience just equals more proficiency with proofs. Get rid of that and call it good.